Dear student, due to coronavirus, school started online classes for your study. So you can subscribe Golden Flower Palia YouTube channel, like and press the bell icon.
Hello students, today we are going to discuss the next topic of electric potential and capacitor. This chapter it is going on electrostatic, it is a part of electrostatics, and till now we have studied what is electric potential and what is electric potential due to a point charge. Okay, so now we are going to discuss about electric potential due to dipole. Okay, and you might be knowing what is dipole because that dipole we have studied in electric field. Once again, recall your memory. What is dipole? Dipole, it is arrangement of equal and opposite charges which are kept at a small distance apart from each other. When these charges are very big and the distance between two of them it is very small, then this arrangement we call as ideal dipole. Okay, ideal electric dipole. Okay, so today we have to study what is electric potential due to dipole, and there we have two positions, not two, three positions are there, so that we have to talk about today. Okay, so what is electric dipole? When two equal and opposite charges are kept at a small distance apart from each other, the arrangement is known as electric dipole. So we are going to discuss about electric potential, electric potential due to electric dipole. Okay. So there we have three situations for finding the electric potential. The first situation it is electric potential on axial position. Okay, axial position, or another name we can give it to end on position. Okay, second it is broad side on position, broad side on position. Okay, that is the point is lying on the perpendicular bisector of the electric dipole, and the third it is at any point. Okay, at any point. So three positions we have to discuss today, and first we will discuss about the axial position, end on position. Okay, so what is end on position? I'm going to discuss here. So there we have an electric dipole. This is electric dipole, and always we need to keep minus charge to the left hand side and plus q charge to the right hand side. Okay, and this you consider as A, it is B, it is the center of the dipole, A to A, A to O, the distance is L, O to B, the distance is L, the total distance of the dipole it is 2L, and due to this dipole we need to calculate electric potential at point N you consider. Okay, at point N we want to find out the electric potential. Okay, so let the distance of point N from the center of dipole it is R. Okay, this is the distance R from the center of dipole. So from plus Q to N the distance will be equal to R minus L, and from minus Q to N the distance will be equal to R plus L. So these are the distances of this point in question from the center of dipole. Okay, thus from the center of dipole that is R, I'm sorry, and from the plus Q it is R minus L, and from the minus Q it is R plus L. Now we have to calculate the electric potential, and before calculating the electric potential we must be knowing that is electric potential a vector quantity or a scalar quantity. So we very much aware of that the electric potential is a scalar quantity. It is not a vector quantity. Electric field is a vector quantity, but electric potential it is a scalar quantity. So when we are calculating something and it is a scalar quantity, we must see the sign of the charge. Okay. So here we will consider the sign of the charge. If we are finding the electric potential at point N due to positive charge, the electric potential will be positive, and that we already have discussed in the last lecture. Okay, so due to positive charge, electric potential is positive. Due to negative charge, electric potential is negative. Okay, so you need to keep remember it is not a vector quantity, so we not need to mention the direction of electric potential. Okay, so electric potential there we have to take the positive and negative sign as per the source charge that we are talking about. Okay, so what is the electric potential due to positive charge and what is the electric potential due to negative charge at point N? Okay, so here we have electric potential due to plus Q charge. Okay, so let it is V1. So V1 is equal to 1 upon 4 pi epsilon naught, and the charge is positive Q, and plus Q is having distance from point N, it is equal to R minus L. So here it is R minus L. Okay, because potential was having the formula 1 upon 4 pi epsilon naught Q by R. Okay, that we have driven in the last lecture how to calculate the electric potential due to a point charge at particular point. Okay, and what was the potential? Potential was the work done to bring a unit positive charge from infinity to the point in electric field. So at point N, due to positive charge, the electric potential will be equal to V1. We have considered it, that is 1 upon 4 pi epsilon naught Q by R minus L. Okay, in the place of R, we have kept R minus L. And at the place of charge, plus Q charge, we are just keeping Q. Okay, due to minus Q charge, the same quantity V2 will be equal to 1 upon 4 pi epsilon naught, and that is Q upon R plus L. But this minus Q charge is a negative charge, and due to the negative charge, electric potential is always negative. So here we will mention negative sign for that. Okay, so minus 1 upon 4 pi epsilon naught Q by R plus L. There it is no square, so don't put a square here, because commonly the students do this the mistake. They are confusing in the formula of potential and electric field. Okay, so in electric field there it is R square, and in potential there it is R. Okay, so you need to keep remember this when we are calculating the potential, we should not put a square. So what is total potential at point N due to plus Q and due to minus Q? So net potential at point P. Net potential at point N. Okay. So that is V net is equal to V1 plus V2. Potential, it is a scalar quantity. So net potential will be equal to the algebraic sum of the potential due to individual charges present in the space. Okay, whatever charges are present in the space, due to each and every charge, we need to calculate the potential at point N, and that we are going to algebraically add them. Okay, so total potential will be equal to V1 plus V2. So just keep the value of V1 plus V2 here. It is 1 upon 4 pi epsilon naught and Q by R minus L. And the V2 it is 1 upon 4 pi epsilon naught and Q by R plus L. Okay, because V2 was in negative sign, so here I have kept it is with negative sign. Okay, this I am going to remove. Okay. Work is over. So total potential at point P, there it will be equal to, take Q by 4 pi epsilon naught as common, and what will be left inside, R minus L minus 1 upon R plus L. Okay, take LCM and calculate it. It will be Q upon 4 pi epsilon naught, R plus L, it is going to be multiplied with 1, R minus L, it is going to be multiplied with 1, but there it is minus sign, so it is going to be changed, R plus L, and they both are multiplied together, R minus L and R plus L, it is equal to R square minus L square. Okay, so there it is. So R and R is cancelled because this R is given in minus, this R is plus. So now what is left inside? 1 upon 4 pi epsilon naught, L plus L, that is 2L. 2L into Q, we can write it as 2QL upon R square minus L square. Okay, so this is a known quantity. We have already studied when we were studying electric dipole. It is electric dipole moment denoted by P. P is equal to 2QL. It is the product of either charge and distance between the two charges. Okay, so it is electric dipole moment. So in the place of 2QL, we can write here P. So 1 upon 4 pi epsilon naught, that is P upon R square minus L square. This is a practical value for the dipole. If we are taking the same for the ideal dipole that I have told you in the starting of this video lecture, that what is ideal dipole, when the two very big charges are kept very small distance apart from each other. So when the distance between the two charges is very small, so we can neglect this L square. Okay, so neglecting L square, so V net will be equal to 1 upon 4 pi epsilon naught P upon R square. Okay, so total potential, it is inversely proportional to the R square. Okay, due to the dipole. So this was for today, and in the next video lecture we are going to discuss electric potential due to a dipole on broadside opposition.
Do self study at home and stay home, save lives. Thank you very much.